classes. Today we are discussing second chapter, sets. Set means a well-defined collection of objects is called set. Set means one group. We are making one group. That group has well definition. One definition. It has one definition. Sets are denoted by capital letters. Here we are denoting capital A. Capital A is equal to A, B, C, D. Sets we are writing in flower brackets. Okay. Inside elements, inside objects we are calling as elements. Elements are denoted by small alphabetical letters. Elements set between we can use belongs to symbol. Here first one is element and second one is set. Element and set between we can use belongs to symbol. Next, here when we are writing belongs to and cancel the belongs to, the symbol is called not belongs to. Not belongs to. Here F is not there in the set. Here F is not there in the set. So that F not belongs to capital A. First one is element, second one is set. Element and set between we can use belongs to symbol. Next, forms of sets. Here we are in set, main two forms are there. First one is roster form. Roster form. Here roster form means elements we are writing in flower brackets, that is called roster form. Next, set builder form. Set builder form other name is definition form. In definition form, definition means we are writing elements, these elements we are writing in definition. We are writing in definition. Suppose one more question they are asking, roster form change into set builder form. 2, 4, 6, 8 is the roster form. E is equal to, E means even numbers. Here 2, 4, 6, 8 are even numbers. Even numbers, this is the roster form. Roster form change into set builder form. Every set builder form consists of x such that x. X such that x is equal to 2n. 2 into n. Okay, even numbers general formula is 2n. N belongs to natural numbers. Okay, this n value is less than or equal to 4. Suppose 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. Less than or equal to 4. Sometimes we are taking n less than 5. N less than 5 means we can take less than 5. Below 5 natural number is 4. Up to 4 only take. 2 4s are 8. Next, very important in annual exam also, exercise 2.1, 5th bit, 6th bit, 7th bit. Here roster form change into set builder form change into roster form. One mark question. Every year they are asking one mark question. We must practice these problems. Exercise 2.1, 5th bit, 6th bit, 7th bits. Universal set. Universal set is denoted with mu. Mu means a set contains all given sets. A set contains all given sets is called universal set. It is denoted by mu. Here symbol is like rectangle. Universal set we are writing in rectangle. All elements we are writing in rectangle. Suppose sets we are writing in circle. All sets in universal set. A set contain all sets. A set contain all sets is called universal set. Next, types of sets. If you take empty set or null set or void set, it has three names: empty set, null set, void set. It is denoted by pi. A set has no elements. A set contains no elements is called empty set. Empty set. It is denoted by pi. It is denoted by pi. Pi is equal to empty bracket. Here no element. Suppose like this is there. It is not empty set. Not empty set. Because it has element pi. Element pi. So that if you take only no elements, empty set means no elements. Next, singleton set. A set has only one element is called singleton set. Example, even prime number. If you take even prime number is 2, it has only one number. Even prime number is 2. That is singleton set. Suppose if you take lady prime ministers of India. In India, only one lady prime minister is there. That is Indira Gandhi. Indira Gandhi is only one element. Lady prime ministers of India is also singleton set. Next, finite set. A set as number of elements are finite is called finite set. You can countable numbers. Suppose if you take in your class we can count the students. 40 students are there, 42 students are there. It is finite set. A set has number of elements are finite. I am taking here even numbers up to 10. 2, 4, 6, 8, 10. Here how many elements are there? 1, 2, 3, 4, 5. Here number of elements are countable. So that it is called finite set. Next, infinite set. A set as number of elements are infinite. A set as number of elements are infinite is called infinite set. If we take natural numbers are infinite. Whole numbers also infinite. Integers also infinite. Rational numbers also infinite. And irrational numbers also infinite. And real numbers also infinite. These all are infinite sets. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. These all are infinite sets. Next, cardinal number of set. What is the meaning of cardinal number of sets? In a set, number of elements, we can count the number of elements is called cardinal number of set. Suppose example A is equal to 3, 4, 5. Here how many elements are there? 3 elements. Number of A is equal to 3. Cardinal number of set is denoted by number of A. We can read n of A. This only we are reading as number of A. Next, equal sets. Two sets have same elements are called equal sets. Suppose I am taking two sets. A is one set. 2, 3, 5, 7, 11. These are all prime numbers. Next, B also I am taking 3, 2, 5, 7, 11. These are also prime numbers. Here 3 is equal to 3, 2 is equal to 2, 5 is equal to 5, 7 is equal to 7, 11 is equal to 11. These two sets have same elements. Two sets have same elements. All elements are equal here. Condition all elements are equal. Then these two sets are equal sets. A is equal to B. Here equal sets symbol is equal. Equal sets symbol is equal. Next, equivalent set. Here small difference is there. Equal sets and equivalent sets. Equivalent sets means two sets have same number of elements and different elements. Same number of elements are same. Number of elements are same, but elements are different. Suppose example here A is equal to 1, 2, 3, 4. Here how many elements are there? N of A is equal to 4. And B is equal to A, B, C, D. Here how many elements are there? 4 elements. N of B is equal to 4 elements. Here also 4 elements. Here also 4 elements. Number of elements are equal, but elements are not equal. Here small a is equal to not 1. Small b is equal to 2. Here elements are different. But number of elements are equal. So that these two sets are called equivalent sets. Equivalent sets symbol. This is the symbol for equivalent sets. A equivalent to B. A equivalent to B. Subset. What is the meaning of subset means? Suppose they given two sets. In two sets, first set all elements present in second set. Then first set is called subset of second set. Subset symbol is, this is the subset symbol. Like C. Next, empty set. Empty set is subset of every set. And every set is subset of itself. A subset A. Next, superset. Same like this will be in two sets. First set is the small set and second set is the big set. Small set is called subset and big set is called superset. Superset means, superset symbol is like this, reverse C. B superset to A. Here A is subset to B and B is superset to A. Next, power set. What is the meaning of power set? A set contains all subsets of given set is called power set. It is denoted by P of A. Okay. Suppose example A is equal to X, Y, Z. There how many elements are there? 3 elements. N is equal to 3. Then P of A. P of A is equal to, we can write all subsets. We can write first flower bracket. First empty set is subset of every set. Next single element X. Next single element Y. Single element Z. After that we can follow the order X, Y, 2 elements. Next X, Z, 2 elements. Next Y, Z, 2 elements. We can go forward only. After that 3 elements X, Y, Z, X, Y, Z. Okay, these are all subsets of given set. means all subsets of given set is called power set. All subsets of given set is called power set. Here P of A is equal to, here we are getting all subsets. Here number of elements in P of A is equal to formula 2 power n is equal to 2 power, here n place how much is there? 3. 2 power 3 is equal to 8. Our answer is correct or not? Check. 1, 2, 3, 4, 5, 6, 7, 8. Here total 8 sets are there. Next, operations of sets. Very important. This chapter is depend on operations of sets. First, union of sets. It is denoted by U. Second one, interjection of sets. It is denoted by interjection symbol, reverse U. And third one, difference of sets. It is denoted by minus. Next, first union of sets. In given sets, write all elements of given sets. We can write all elements of given set and repeating element write one time. For example, A is equal to 1, 3, 5, 7, 9 and B is equal to 2, 3, 5, 7. Then A union B. Here 1, 3, 5, 7, 9 union B means 2, 3, 5, 7. You can write all elements here. First 1 write, after that 2, after that 3. 3 is repeating, but we can write one time only. Next 5 also repeating one time, 7 repeating one time, and 9. 1, 2, 3, 5, 7, 9. All elements of two sets, but repeated element write one time only. This is called union. A union B. 1, 2, 3, 5, 7, 9. Okay. A union pi. Any set union with null set or null set union with any set, then it will become that set only. That set means A. A union pi is equal to pi union A is equal to A. Pi is called union identity of sets. A union B. Set builder form of A union B is equal to X such that X is equal to A union B. Here X belongs to A, first set. Union symbol will become V. V means R. It is the symbol for R. V. X belongs to V. X belongs to first set or X belongs to second set. Okay, it will be a first set or second set. Next, A union B, Venn diagram. George Venn, mathematician, introduced Venn diagram. And Euler and Venn, both two mathematicians combinedly introduced this Venn diagram. So that we are calling Euler Venn diagram. Okay, first we can write rectangle. Rectangle is denoting universal set. For every time when we are drawing Venn diagram, first we can draw the rectangle. Rectangle is called universal set. In this first set, first circle A, second circle B. A union B means all elements of two sets. All elements of two sets. We can shade the two circles. We can shade the two circles. This is called A union B. Next, interjection of sets. In given sets, suppose they given two sets or three sets. Common elements of two sets. Common elements of given sets is called interjection of sets. Interjection of set symbol is reverse U. A is equal to 1, 3, 5, 7, 9 and B is equal to 2, 3, 5, 7. Okay. Now we can find A interjection B is equal to first set 1, 3, 5, 7, 9 interjection 2, 3, 5, 7, 9. What is the common elements? 3 is the common element, 5 is the common element, 7 also common element. A interjection B is equal to 3, 5, 7. Okay, how we can write the set builder form of A interjection B? A interjection B is equal to X such that X. Every set builder form consists of X such that X is equal to A interjection B. X belongs to A. Interjection symbol is AND. X belongs to B. Here this symbol is called AND. Next, A interjection B Venn diagram. How to draw Venn diagram? First we can draw the rectangle. Rectangle is the universal set. First we can draw the A circle and next we can draw the B circle. Common part of two circles is called A interjection B. Suppose if you take two sets have no common elements. A interjection B is equal to 5. These two sets are called A comma B are called disjoint sets. Disjoint sets. Two sets have no common elements is called disjoint sets. Next, difference of sets. It is denoted with minus. What is the meaning of difference of sets? They will give two sets. From first set, we can remove second set elements. Then only first set remaining elements is called A minus B. For example, A is equal to 11, 3, 17, 19. and B is equal to 11, 3, 15. You can do A minus B. First you can write A 11, 13, 17, 19 minus B 11, 13, 15. We can cancel common elements. 11, 11 cancel. 13, 13 cancel. Here remaining elements in first set 17, 19. Here A minus B is equal to 17, 19. Next B minus A. First we can write the B 11, 13, 15. B is 11, 13, 15 minus A means 11, 13, 17, 19. Both will cancel. 11, 11 cancel. 13, 13 cancel. Here only we can take first set elements 15. Here B is the first set elements. We can take here only B elements. Previous we can take only A elements 17, 19. A minus B is equal to only A elements. We can cancel the common elements. B minus A is equal to only B elements. We can cancel the common elements. Here 15. A minus B, B minus A. If you observe, A minus B 17, 19. B minus A 15. These two sets have any common elements? No common elements. So that A minus B, B minus A are called disjoint sets. Next, Venn diagram. A minus B, B minus A. First we can draw the rectangle universal set. In universal set it is denoted by mu. First circle A, second circle B. We can shade only A. Only A is called A minus B. Next we can draw two circles. Now we can shade the only B, that is called B minus A. Here next symmetric difference of sets. Here symmetric difference of sets is denoted by delta. A delta B is equal to formula A union B minus A intersection B. It has two formulas. Again A delta B is equal to A minus B union B minus A. For this Venn diagram, first we can draw the rectangle. Rectangle is universal set. First circle A, second circle B. We can shade only A and only B. Don't shade middle. That is called A delta B Venn diagram. Next, properties of sets. In properties of sets, first we can write the table. Name of property. Here union of sets and intersection of sets. Here first property, closure property. What is the closure property? In numbers also we can learn. 7th, 8th class, closure property. A comma B belongs to mu. Here mu means universal set. Then A union B also belongs to mu. This symbol is called belongs to. Next A comma B belongs to mu. Then A intersection B also belongs to mu. This is the closure property in intersection. Next commutative property. Commutative property is equal to here A union B is equal to B union A, or A intersection B is equal to B intersection A. Next, associative property in union. A union B union C is equal to A union B union C. Again, in intersection, A intersection B intersection C is equal to A intersection B intersection C. This is associative property in intersection. Next, identity. A union pi is equal to pi union A is equal to A. Identity means we are getting same set. Here A means again we got A only. Then pi is called union identity. Next, intersection. A intersection mu is equal to mu intersection A is equal to then A. We are getting same set. So that mu is called intersection of, mu is identity. Mu is identity of intersection of sets. It is the identity. Okay. Next, distributive property. A distributive property. In distributive property, at a time we are getting intersection symbol and union symbol. Both symbols are we are getting. A intersection B union C is equal to A intersection B. A intersection for first set and A intersection for second set. This inside symbol is coming outside. A intersection B and union is coming outside, and A intersection for C. A intersection B union C is equal to A intersection B union A intersection C. Next, reverse. Here previous union is inside, intersection is outside. Now union is outside, intersection is inside. A union B intersection C is equal to A union for first one, A union B, and intersection is coming outside, and A union for second one, A union C. A union B intersection C is equal to A union B intersection A union C. These two are distributive properties. Next, one formula, number of A union B is equal to number of A plus number of B minus number of A intersection B. Here, if A comma B are disjoint sets, two sets have no common elements, the two sets are said to be disjoint sets. Number of A intersection B is equal to pi. In disjoint sets, number of elements in A intersection B is null set is equal to pi. Then number of A intersection B will become 0. It will become 0. Then number of A union B is equal to number of A plus number of B. Okay. Here number of A intersection B plus 0. 0 no need to write. Then number of A union B is equal to number of A plus number of B. This is the condition for disjoint sets. Okay. Sets is easy chapter. If you practice again, easily we are getting 7 to 8 marks, so that you can practice sets. Thank you.